Hey everybody, welcome to the next video. This should be Wednesday, March 25th. And today we're going to launch into multiplying. So I hope we're getting the rhythm of this. I hope we're figuring things out. Some of the systems on Google Classroom and the way I'm running things have changed, but I hope we're all getting the hang of it. So let's jump in. We're going to jump to our workbooks and get started. Okay, we are now in our workbook on page 275. And we're going to jump into the next lesson. So today what we're going to look at is multiplying polynomials. And we're going to keep it fairly small. We're going to multiply a polynomial by a monomial. So that's like having a single term out front of my polynomial that I'm going to multiply by. This is something we did in grade 9. So today will be a good refresher. And then we'll be able to expand it tomorrow. So we'll jump down. We're going to start by using algebra tiles. And I've got some examples that we'll try together. The first one, 2 times x plus 1. Well, that's represented in this system. I've got a grid set up. I've got 1, 2 set up on the top, and then x plus 1. Well, there's my x, there's my plus 1. I've got that set up. Okay. And what we're going to do is we're going to multiply across and multiply down, and we're going to fill the space. So I'll actually show you that with my real tiles that I'll pull up here. So here is my grid. We are multiplying 2, so I can bring in those real tiles, by x plus 1. So there's my x tile, and there's plus 1. So that's what we have in our workbook. Just a refresher, maybe I'll drag this down. The 1s tile was called a 1s tile because it has an area of 1. Base times height, 1 times 1 is 1. The x tile was called an x tile because it has an area of 1. 1 times x is x. And the x squared tile, the really big one, is an x by x tile, which gives it an area of x squared. What I am doing here is I'm looking at the dimensions. I'm going to multiply this piece by everything down the row. And then I'm going to go down and I'm going to multiply this piece by everything down the row. So what I have is x times 1 needs to fill in this space here. Well, x times 1, anything times 1 is just itself. So x times 1 would be x. And it fills in the space. Dimension of 1, dimension of x perfectly lines up. Same thing, x times 1, filling in the rest of this row. X times 1 is x. There we go. And the next one, 1 times 1, filling in this bottom is 1. And I need to continue and multiply the other piece. 1 times 1 is 1. So my answer is represented by the filled in space. 2 times x plus 1. That's what we just did. The answer is 2x plus 2. So I'll go back and we'll fill the rest in. So what I did, I said 1 times x is x, and I shaded in. And 1 times x is x, and I shaded in. And I should make my rectangle actually look like a rectangle. 1 times 1 is 1. 1 times 1 is 1. For an answer of 2x's plus 2. Absolutely. So multiplying polynomials, I can always draw this chart. I can always multiply it with tiles and find my answer. My answer is a thing on the inside. Let's do one more, and then we'll do them without the physical tiles. So the next one was x times x plus 3. So I'll get rid of what I have. X on the top, x plus 1, 2, 3. X plus 3. I represent them with tiles. My goal is to now complete the shape, and I'm going to fill in a rectangle. While I start, I'm only multiplying by one thing, and then I go down to the row and multiply the rest. Multiply the rest, multiply the rest. X times x is x squared. It fills in the area. I have a dimension of x. I have a dimension of x. Go to the next one. 1 times x. 1 times x is x. And notice I line up the dimensions. Dimension of 1, dimension of 1, dimension of x, dimension of x. And again, 1 times x, x. I line it up the same way. 1 times x, x. and it perfectly fills in my space. So my answer, x squared plus 3x, everything I have in the middle. The answer was x squared plus 3x. And if I fill that in, there's my x squared, and there's my x. So my rectangles don't have to be perfect, but I have to do a good enough job to fill the spaces adequately to know that dimensions are supposed to line up. Okay, I will do C without actually showing the physical tiles. So what I see is -3, there they are, x minus 1, there's an x, there's -1. I'm going to do the same thing. The x multiplied by -1, multiplied by -1, multiplied by -1, and the -1 multiplied the whole way. So x times -1 is -x. So I fill in a rectangle, but I don't shade it in to show that it's negative. Same thing. X times -1 is a -x. Fill it in. Fill it in. Now to the bottom. These are all the same. -1 times -1 is 1. -1 times -1 is 1. -1 times -1 is 1. Okay. There you go. There you go. There you go. My answer, the result of this multiplication, -3 times x minus 1 is -3x plus 3 for those positive 3's. Okay, here's where I would invite you to pause the video and attempt the next two on your own. I'm not going to explain them. I'm just going to write in the answers, but I would encourage you to attempt them on your own. So pause and then start up in a sec. So there's D, not explaining, just provide the answer for you. You have 2x squared, and you have 4 negative x's, so minus 4x. Here's the next one, again, not explaining. And there's your answer. You have 2x squared minus 2x. Okay, so you should have got the same answers as me. Maybe you could ask for clarification if you didn't. All right, moving on to the top of the next page. Great question. Okay, each diagram below illustrates the result of the product of a monomial and a binomial. Okay, well, this is like saying, here's the answer. Can you go back the other way? Okay, can you fill in what was multiplied by what? Okay, and the reason there's two diagrams is there's actually two options. So here's another opportunity if you want. Pause and attempt these ahead of me. I will go ahead and show you both. So it says, state the polynomial represented in both diagrams. Yeah, absolutely. What I notice is at the top in diagram 1, this dimension is an x. So the to way I multiply to a dimension of x is if I first had an x tile. And the other one would have been the same. It would have been an x tile. The only way to multiply to x squared is to have an x by x. And I'll make them positive. Positive x times positive x gives me positive x squared. But then I think for diagram 2, couldn't have been the other way. It could have been a negative times a negative gives me a positive. So maybe this was negative x times negative x, and that still works. And then I go down to the other one. I say, well, this is another x squared. Well, you have your x at the top. I need an x here. X times x gives me x squared. Or, just like before, negative x times negative x. So I can fill in that one. X or negative x. And the last one to fill out is what goes in this little bubble here. Well, you know it's x times something is supposed to result in a negative x. Well, x times -1 gives you a result of negative x. Or the opposite, negative x times +1. gives me a result. So my two diagrams, my 2 would be x times 2x minus 1. That's one option that gives me this answer. Or the other way is to say it was a negative x times negative 2x plus 1. Both of these products actually give me the same answer. Okay, and this is actually something that we're going to look at later in this unit is, well, how do I go backwards? If I'm given the answer, how can I write it as the product of two things? And the interesting thing here is sometimes there's more than one option. Sometimes there's more than one answer. Okay, so I'm not actually going to do the questions with it. That's all I wanted us to do. Okay, moving on to the top of the next page, we are going to reintroduce the distributive property. And this is something you certainly should remember from grade 9, maybe even from grade 8. The distributive property. Okay, we just went through and we just did all of these questions with tiles. So in class example 1, we showed that 2 times x plus 1 is 2x plus 2. And x times x plus 3 is x squared plus 3x. And 2x times x minus 2 is 2x squared minus 4x. And so on and so on. Okay, we answered all of these with tiles. Well, what I'm going to show you is, okay, we don't need tiles to do this multiplication. If I have a monomial in front of a polynomial, I can use the distributive property. Okay, and it has the distributive property laid out for us here, saying this. Okay, there's both ways there. The distributive property says if I have something out front, so A times this set of brackets, A is multiplied by B. It gets multiplied in, and A is multiplied by C. So I draw that with an arrow. Distribute the A. Both pieces are multiplied. Or the other way around is if that thing is on the back end, still doesn't matter. It's distributed. If you have a piece multiplying a bracket, all of the pieces get multiplied by the bracket. Okay, so in your first example here, use the distributive property to determine these products. A, 4 times 3x plus 1. Well, I would multiply 4 times 3x. 4 times 3 is 12x. But then I need to remember, I'm not just multiplying the first term. I distribute that into all of the terms. 4 times 1 is 4. So 4 times 3x plus 1 is the same as 12x plus 4. Okay, next one. Negative 5 times 2x squared plus x minus 6. Distributive property. All of those pieces get a negative 5. You get a negative 5, and you get a negative 5, and you get a negative 5. It's like Oprah. You get a car, and you get a car, and you get a car.
Everybody in the audience, now listen to me carefully, is being given a special package, and I don't want you to open it. You get a car! 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 You get a car!
Well, negative 5 times 2x squared. Negative 5 times 2 is negative 10 x squared. This would have a coefficient of 1x. Negative 5 times 1x is negative 5x. Multiplying the coefficients. Negative 5 times 1 is negative 5. And finally, the number at the end, the negative 6. Negative 5 times negative 6 is a positive 30. And you have your answer. There it is. That's the distributive property. Okay. X cubed minus 2 all times x squared. Distributive property works from the backside as well. X cubed times x squared is x to the 5. That's from multiplying powers. That's the last unit. Negative 2 times x squared is negative 2x squared. And finally, the last one. Negative 3x times 7x times negative 2y times z. Multiplying, distribute the term out front. I'm distributing that negative 3x. I get negative 21x squared. And next one's a negative times a negative, so plus 6xy. And a negative times a positive, negative, so minus 3xz. So my power laws and my variable laws are all coming back. All right. In the example above, we've written a product of polynomials as a sum or difference of terms. So this is expanding it out. Okay. We are expanding this out. We are simplifying. We are doing the multiplication. Okay. All right. Here's a couple examples. Okay. Not too many. We'll do a couple examples here. And then I'll let you practice more and more and more. So expand and simplify. I need to remember that the distributive property is only there in front of a bracket. Okay, I'm not always doing this. I'm doing this when I'm multiplying things out front. So the first one, you have 6 minus 4 times the x, 8x plus 1. Well, what I need to remember is I need to distribute information in front of a bracket. So here, I have a 4 in front of this bracket, and it happens to be negative because I'm subtracting. So I am going to distribute the negative 4 into the bracket. 6, and then distributing the 4, 4 times 8, negative 32x, negative 4 times 1, minus 4. I distribute the information out front. So the distributive property will be part of questions. It's things that I have to do within the question. And then I write this in the best possible way. Negative 32x, that is a variable that would go first. And then my constants plus 6 minus 4. Final answer, negative 32x plus 2. Always simplifying, always simplifying, always simplifying. That's what we did in the first 2 days. Alrighty, on to the next one. Distributive property to the bracket it touches. So 4 times 2x minus 3, and minus 2 times the x minus 6. Well, 4, that gets distributed to the bracket it's touching. And the negative 2, that gets distributed to the bracket it's touching. Only distributed into the bracket it's touching. 4 times 2, 8x. 4 times negative 3, minus 12. Okay, remember to distribute this negative 2. It was a subtract 2 times this bracket. So negative 2 times x is negative 2x. And negative 2 times negative 6 is positive 12. Distribute as I go. And now it's a simplify. Gather your like terms. X's together, 8x minus 2x. Constants together, minus 12 plus 12. 8x minus 2x is 6x. Hey, minus 12 plus 12? I gave you $12 and then I took away $12. You don't have anything. So you might be tempted to write plus 0, but plus 0 is a redundant statement. It doesn't mean anything. It's unnecessary. Don't write it at all. 6x. That's my final answer. And on to C. This one's somewhat of a doozy. 5x times that first bracket. And then I'm subtracting the second polynomial. So I can distribute the 5x. You get a 5x, and you get a 5x, and you get a 5x. 15x cubed, x times x squared is x cubed, minus 35x squared, plus 5x. And then I'm subtracting that polynomial. This is what we did on the second day. Subtraction, I distribute the negative. We've already been doing this. Subtract 4x and subtract 3x squared. So I have the distributive property. That's how I can look at subtraction. All right, gather my like terms and go together. I have 15x cubed. That's the only x cubed term. That's different than your x squareds, minus 35x squared, minus 3x squared. Those are different. Those are together. And then my x's could go together, plus 5x minus 4x. Equals 15x cubed. It's the only x cubed. Now your x squared. You lost 35 of something, you lost 3 more. Altogether, you lost 38x squareds. And plus 5x minus 4x, well, I'd only have 1x, which I don't have to write the coefficient of 1. I can just say x. You have one of them. There you go. There's your answer. And that's the distributive property within questions. So sometimes I'll just ask you to do the distributive property, but more often it's part of what we're doing. So I need to include it and know to use it in questions. All right. Last question. This one's a doozy. Determine the simplified expression for the area of the given shape So it's the same question. It's asking me to do it two different ways. One is by adding the area of two rectangles. The other is by subtracting the area of two rectangles. I'm actually going to show you the best way to do it, okay? And which is the second option, actually, which is subtracting. So let's forget about this one. We are going to look at, hey, how could I find the area of this weird thing? By subtracting the area of two rectangles. And what I'm going to look at, okay, is, okay, here is the shape that I have. Okay, it's got some labeled dimensions. And what I want us to think about, when we look at it is, I've got this shape. Well, if I filled in that bottom corner, okay, what I have is a rectangle. I have a 3x plus 2 as my top dimension, my length, and I have a 4x as my side dimension, my width. Really, if I look at this shape, the whole thing is just a rectangle. So I could easily find the area of this rectangle, base times height. But my blue shape, the thing I'm looking for, is not the full rectangle. I could find the area of the full rectangle and then just remove the corner piece. So if I could find the area of the whole rectangle and the area of this pink rectangle, the bottom rectangle, and go the white rectangle, subtract the pink rectangle, I have my area. So that's what I'm going to do. Okay. So let's go, and maybe I'll pick different colors than what I just drew there. Okay. So we'll do the whole thing. Let's call purple. Okay. I have this purple rectangle that I am looking to find the area of. And then I'm going to subtract the red one, the one in the bottom corner. Okay, I could say area equals the area of the purple one, or the area of the big rectangle, minus area of the red one, or area of the small. So I'm going to go to the side and I'm going to figure out, well, what is the area of the big one? What is the area of the small one? Okay, I think the area of the big one is easier. Area equals base times height, or length times width. When we're dealing with rectangle, it's the whole bottom dimension, the whole side dimension. So the whole distance across is 3x plus 2. That's my base. The height, or the side of this thing, that's 4x. And if I wanted to multiply that, I'd need the distributive property, which says multiply both terms. You get a 4x and you get a 4x. So my area of the big one is 12x squared plus 8x. Great. And I can actually plug that in over in my formula. 12x squared plus 8x. That is the big rectangle. Area equals. So now, if I was able to find the area of the small one, I could subtract it away and I'd be done. So what I'm looking at now is the area of the small one, which again would equal base times height. But the issue is I don't have the dimensions of that red one. So I have to do a little work and I have to figure it out. Okay. I think the easier dimension to figure out is the height, this side. Okay. Because I know it's part of the way across the whole thing. From this corner to this corner, it is part of the way. It's not the whole way, just part. Okay? And I know the whole way is supposed to be 4x. Okay? The whole distance across is 4x. From the top to the bottom is 2x. So I need to figure out, well, what would remain? The whole thing was 4x. I've gone 2x. I can calculate that quickly. The whole thing across is 4x. Take away the 2x that's already accounted for, and I get a dimension of 2x, which makes sense because this dimension 2x plus this dimension 2x has to equal 4x. All right, I'm going to do the same exact thing, but I'm going to find this dimension, the bottom one, the base, which says the whole way across is 3x plus 2. you've already taken into account x plus 5, which means I should do a subtraction. 3x plus 2, 3x plus 2, and I'm going to go maybe off on the side here. 3x plus 2, subtract your x plus 5, and I'll calculate that. 3x plus 2, there's no information up front. The next one, I have to distribute that negative. Minus x minus 5, that's from our subtraction lesson. You get 3x minus x plus 2 minus 5, which is 2x minus 3. There we go. Now I have my bottom dimension or my base dimension. So a bit of a more challenging question. I got to find some information on my own. But now I can plug in the base of 2x minus 3, the height of 2x, and again, using that distributive property, distribute the 2x. 2x times 2x is 4x squared minus 6x. There we go. That is the area of the small one. So I have 12x squared plus 8x, and I'm going to take away 4x squared minus 6x. That's going to give me my ultimate answer. Okay. If I'm going to do that, first bracket has no information up front. There's no distributive property. But then the next one, absolutely. I'm subtracting this polynomial, which means I need to subtract both of the pieces, or I need to do the distributive property. Minus 4x squared. And then subtracting negative 6x. Subtract a negative is like adding. So it's really a plus 6x. Okay, that's the little hiccup. Now, gather your like terms. Put my x squareds together. 12x squared minus 4x squared, done. Put your x's together. Plus 8x plus 6x, done. Area equals 12x squared minus 4x squared, 8x squared. And plus 8x plus 6x plus 14x. There you go. That's my final answer. That is the area of the original shape, the thing I started with, which was a big rectangle, taking away a little rectangle in the corner. Okay. If you wanted to attempt that question on your own, you absolutely could. For question 1, where it's, could you figure out, maybe it's this rectangle plus this rectangle, could you figure out that part? Okay, which I think is not too hard. And that's it. That's multiplying using the distributive property. So move down, I'll show you your homework. Okay, page 278. And it looks like a lot, but it's not actually a lot. I'm only asking you to do the odd letters, which if you don't know the concept of odd letters, that means you do A, but not B. You do C, but not D, E, G, I, etc., etc. The first, third, fifth, seventh, ... letters, right? The odd letters. So there you have it. That is the lesson for today and the homework. As always, if you have a question, submit it in the form or send me an email and I will get back to you. Thanks for watching. Thanks again for watching, guys. If you have any questions, let me know in the Google form or just in a comment if you want, and I'll get back to you with a quick video. Enjoy the rest of your day, and I will see you guys tomorrow.